The discussion on the error barometer is probably one of the most important discussions we're going to have, and it deals with what is probably the most difficult concept to understand in statistics, and that is the sampling distribution. So I'm going to step you through how I did it. So I did it myself for a particular country in question, and explain what it is we're doing along the way. So I chose the country Lebanon. I've had the pleasure of knowing 3 people who came from there, and I just found them to be exceptional individuals, just incredible people. And so I'm very much interested in it. And I was interested in the question about whether or not they were religious. And so I took these 2 categories, religious and somewhat religious, and grouped them. And then not religious was another category. And if you look at the data set, you'll see that these are actually very small, and we can end up deleting them. And so I started off with my variable. And so religious and somewhat religious was my category of interest. Now, one of the really important things here is the fact that in this problem, we have 2 populations. One population you're very familiar with. So in this case, I have the population of individuals. And in part 1 of this discussion, I made a guess as to what percentage of the entire population was in my category of interest. Okay. So I made an educated guess or a hypothesis. So my hypothesis was that the population percentage was equal to 70%. So I believe right now, without looking at any data, the percentage of all of Lebanon that are somewhat religious is 70%. And what that means is that if I knew the data for the entire population, if I was an omniscient being, right, I could read everyone's mind, and I had the data for the whole population, so I had all of the yeses and nos, I would go ahead and plot that, just like we did in Module 3. I'd make a bar plot. And this would be roughly 70%. And the no's would be roughly 30%. Okay. So these would be the percentage. So on the y-axis would be the percentage in each category. And that was part 1. In part 2, what we're going to do is we're going to test your guess. So this is all part 1. So in part 2, we're going to look at a sample. So I'm going to go to the data sets on part 2, and I'm going to download those. So for my case, I had Lebanon, and this is my data set. This is just a very small snippet of a huge data set. So I selected 6 questions from well over 100. It's a very, very large survey. And I'll go ahead and save that. Okay. And then I will import that into StatCrunch. And there we are. Oh, I have it open. I need to close it before I can open up another program. Okay. Yeah, if you have a data set open, StackCrunch will not allow you to import it. And I'm going to do what we learned about in Module 3. We're going to do exploratory data analysis. I'm going to sort the variables, make sure that they're okay. So data, sort. Hold on a second. There we are. Okay. Response to question. And you can see that we have a few people that declined to answer. Okay, maybe it says do not read. Maybe they didn't read. Don't know. Maybe they didn't understand the question or they didn't want to answer. Not religious. So we look at our data set and it's rather large. Somewhat religious, okay. And I'm going to delete these people because they're not relevant to my data set. You don't have to, you could or could not, okay. All right, so now I have everyone that's in these 3 possible questions, and I've grouped 2 of them in one category. So I'm going to go to stat, tables, frequency, and I'm going to click on frequency and percentage of total, which is what I want. All right. And there we are. And so I see that 21.98% are not religious. So if you do the math right, what is that? 78.02. So I know that in my sample, and I'm going to look at my sample size here, my sample size ended up being 1,497. That's a pretty large sample. I got a sample percentage. Remember, P is a sample percentage. And let's go back and just check this to make sure. So if I subtract 100% from this, right, I'm going to get 78.02, roughly. And I could just round it off to 78%. And the question is, does this sample percentage, is this consistent with my guess? Does it support the fact that the population percentage is 70%, or is it evidence that it isn't? And this is going a little bit into our next module. Now, to understand how to interpret the sample percentage, we have to look at a different population. And now we want to look at the population of sample estimates. So what we're actually really interested in here is we're interested in the population of sample estimates, or in this case, the sample percentage. The population of individuals is a real physical population. The population of sample percentages is not. So what I'm envisioning here, and this is the hard thing to wrap your mind around, I'm envisioning that I'm taking samples repeatedly. So I would take this sample, record what percentage was in my category of interest, throw it back, take another sample of 1,497, compute that sample percentage, put it back, and I would do this over and over and over again. And the answer is, what does this population of sample percentages look like? We know that we don't get the sample percentage, the same sample percentage every time. Okay, so if, for example, I was to do the survey and take another random sample of 1,497 people, the likelihood that I would get 78.02% is very small. So the sample percentage is also a variable. It varies from sample to sample. So it has its own distribution. Just like this is the distribution of individual values in the population, I'm interested now in the distribution of sample percentages. And this hypothetical population of sample percentages is one that doesn't exist in the real world. Okay? I want to link this up with something we learned earlier. So you guys might remember in one of the lectures, we did this little simulation. And I'm going to simulate what I would see. So if the true probability of success was 70%, and I took a sample size of 1,497, okay, and I drew one sample, okay, here I got 80.3%. Okay, so I didn't get 80%. And I'm going to draw again and again and again. Notice these are not individuals. Each of these values comes from an entire sample. This is a summary statistic. And I keep doing this over and over and over again. You can see that these values begin to build up a pattern. If you focus here on the mean and the standard deviation, you'll see they're not changing very much. Okay. I keep doing this. I have 40, 50 samples. Okay. So after 100 samples, this is what I have. If I collect 100 more samples, okay, you can see that the pattern builds up faster, okay? And you can see that this sample percentages begin to form a pattern. You can see that very clearly. They're forming a normal distribution. Okay? And this is what the central limit theorem tells us. It tells us if our sample is good, remember back to module 2, good means that it's random or at least representative of the population and it's large enough. We have to test these conditions, right? So the central limit theorem says that if our sample is good, and I strongly suggest you to go back and look at those conditions, okay? To make sure that you're familiar with them. It says if our sample is good, then we know something about sample percentages. We know that P, the sample percentage, has a normal distribution. And the mean of these sample percentages, okay, for this normal distribution, the mean is equal to the population percentage. And we expect that. Since the sample is random, we expect the estimates to be centered around the mean, okay, our parameter. And we also know the standard deviation. We know that the standard deviation is equal to, and for some reason my pen stopped working. Give me a second. Okay. So the standard deviation of the sample percentages is equal to pi times 1 minus pi divided by n square root of. And we have an Excel file that already does this, right? So the Excel file says, okay, if it really is 70%, right? And I should have put in 70% and not 80% in that simulation. Sorry. Okay. And I have a sample size of 1,497, right? This is this Excel template we used. Tells me my standard deviation is roughly 1.2%. Okay, 1.18%. So in this case, I'm assuming that this is 70%. And I know as a consequence that if this is 70%, the standard deviation is roughly about 1.18%. try this. There we go. And now what we want to do is we want to ask the question. So this is the key part. We want to ask, how likely, and remember, how likely is statistics speak for percentile? How likely am I to get a sample percentage of, what do we say? I got 78%, right? 78% from a sample of 1,497 individuals if the true population percentage is 70%. Okay? And so what I'm doing here is I'm testing my hypothesis. Okay? I'm testing my hypothesis using the sample data. This is what we're doing. So I want to test my educated guess. I want to test my hypothesis that the population percentage is 70% using my sample percentage. Okay? This is the key here. So if my guess is correct, and pi really is 70%, then I know that sample percentages have a normal distribution. They're centered around 70%, and they have standard deviation of 1.18%. So this is what sample percentages look like from my hypothetical population. And I'm going to round off 1.18 to 1%, okay? For the purposes of what we're doing, it doesn't make a huge difference. So I'm going to sketch out what this distribution of sample percentages from my hypothetical population look like. And now I want to ask, how likely is it I got a sample percentage of 78%? Well, 78%, right, is way out here. This is my observed sample percentage. This is my data. And I know how to answer that question, how likely. Okay? I know some things about normal distributions. I can compute percentiles using StatCrunch. I can use the empirical rule. And I strongly recommend you go back and you review that in, I believe it was module 4, if I'm not mistaken, on the empirical rule when we were talking about z-scores and measures of relative standing. Okay, and there are ways that we can answer that. So that's what we're trying to do here. Okay, that's kind of the goal of this discussion. You're making a guess. You're collecting data to test that guess because the central limit theorem lets you figure out what data from your hypothetical population should look like, and then you can go ahead and use that. All right? Now, one of the things you might say is this is stupid. I had no idea what the population percentage is, and I'm way off. And you're absolutely right, and so am I. If you look at this, I'm 8 standard deviations away. What does the empirical rule tell you? Is that unusual or not? Highly unusual. Highly, highly unusual. So there's 2 goals to this. First of all, it's to learn a little bit about other parts of the world. I don't know what percentage of people in Lebanon are somewhat religious. Now I know. So statistics, we always say the cool thing about doing statistics is you get to play in everybody's backyard. You get to learn a little bit about a lot of different things. But the other thing we're going to do is later on we're going to say, okay, how do we analyze data when we have no clue as to what the population percentage is? Notice that in one sense this was a stupid discussion because I had no clue And because of the large sample size, I was very likely to be wrong. So when we get to confidence intervals, we're going to revisit this. And we're going to say the smarter way, the way I should have done this, is I should have put my sample percentage here, and I should have put a little error bar called the margin of error around my estimate. And I should have said, I think the true population percentage is in this interval. So the other part of this discussion is to help you learn what you can do with data sets and why you want to do them, when it's appropriate to do what. So we're going to revisit this data set in at least one other discussion, and I hope you're enjoying it. And if you have any questions, I'll be available this weekend. Definitely give me a shout out. I'm more than happy to help. All right, thanks.